So why did we choose to create our own video conferencing platforms? Actually, there are a couple of issues with the products already in the market. So the existing product decrypt our data on their server before transferring it to the recipient side. Sorry? So the biggest platform in this field, Zoom, provides security between user and server, but the encrypted data is decrypted at the server, not at the other end. So our data technically can be manipulated, interfered, or breached on the server. Zoom also admitted that some of the domestic data sent to the server outside of the US. So all of them are real concerns for current users of video conferencing tool in the market. So what are we proposing actually to address these issues? So our proposed solution is to use Jitsi. By using Jitsi's open source library, we have developed our own video conferencing application. It provides end-to-end encryption. For this application, specifically, we set up our own cloud. So using Jitsi does not require any installation on the client side, which is an advantage. So next slide, please. At the very high level, as I said, Jitsi has end-to-end encryption, no license fees required. It gives the ownership of the entire application to the owner. It has recording and live stream features. So now Chitra will talk about the competition and the market analysis.
Thank you, Gonal. So to begin with actual video and web conferencing platforms, we have a lot of remote employees and staff who can easily collaborate and communicate with their colleagues. That being a major use case around actually using tools like Zoom, which is actually occupying the largest chunk of market share, about 36%, with 29,000 domains plus growing. Next slide, please. Followed by GoToWebinar, which is about 22% and is also growing, and Cisco WebEx and On24, and Adobe Connect and Click Meeting. So these are the top 10 market shares with the tools, and like Gonal said, Zoom occupies or is the biggest market share eater in this case. Next slide, please. So a little bit about pricing. So all these tools, while they actually have enterprise versions, they also come with a basic free plan, but with a couple of contingencies around limited time to interact or call. And we kind of mapped out a little bit about Zoom because we are comparing our tool to Zoom and how we could want to scale it. So we have a bunch of few plans, being basic, pro, business, and enterprise, and it's all dependent on the number of hosts and the pricing model. And it starts with a minimum price of $10. Next slide, please. So a little bit about the timeline and how Jitsi was actually formed. So back in 2003, Emil, a student in the University of Strasbourg, created JS Phone. And moving forward, he founded a company called BlueChimp, which actually employed some of Jitsi's main contributors initially, and they offered professional support. And in 2012, Jitsi actually added the ability to actually have a video conferencing capability based on the concept of routing and video streams. And in 2014, using a prototype from Philip Hankel as a basis, the community itself started the whole Jitsi Meets project, a web conferencing application that would counter Hangouts and Skype. And in 2015, Atlassian, an Australian company, everybody's holy grail for ticketing systems, Jira, actually acquired BlueChimp, making a long-term investment in keeping Jitsi more of an open source community-based platform. And in 2008, finally, 8x8 acquired the Jitsi technology from Atlassian, and it is powering through all the video meetings and conferences within the company. And who is actually using Jitsi? So since 8x8 acquired, it's actually implemented end-to-end video conferencing capabilities within the company. We have Comcast, we have Greenpeace, we have University of Strasbourg, and we also have Symphony, as a lot of founders came from the company Symphony. So a little bit of market share globally. for Jitsi, at least on a web/desktop basis, we see a lot of monthly active users coming in from Spain or Europe in general, and the second dominant market across the world is coming in from South America, being Argentina. So we did a quick SWOT analysis to understand what are strengths, problems, and opportunities and threats were. So the strengths being from a security standpoint, end-to-end encryption, what communication is actually handled between the users is encrypted. Security in terms of ownership of data, meaning that this company or this tool wouldn't sell users data and privacy. The third thing being open source, a lot of community support in terms of feature enhancements, and a lot of inputs in terms of growing and scaling. And the fourth one, it's free to use. In terms of opportunities, we came across the increasing need for video conferencing, given that we are in a pandemic, and more of a market need, given that a lot of companies have gone remote, and also the university is remote for the coming few months. Weaknesses was around long-term development time. Since it's open source, it is also difficult to scale unless we have like dedicated engineers and product managers around it, and in-house IT support and development. So basically resourcing is also a weakness given that it's open source. Threats were mostly around market dominance, given that Zoom is still dominating the market as of today because of its branding, and the second, it's being open source so people can set up their own system.
So now I'm going to talk about concept design and architecture. This is a little bit complicated schema, but I'm going to summarize it into 3 parts. On the left-hand side, we have Jitsi Meets, which is the web front end. It doesn't require any installation on your desktop machines. You can run it on web browsers. In the middle, we have the Prosody, which is the XMPP server. And on the right-hand side, we have the video bridge, which hosts the entire Jitsi Meets sessions. Now, if we're going to introduce components, let's start with Jitsi. Jitsi Meets is an open source JavaScript application, which is hosted on Video Bridge. Currently, we have a running and tested Jitsi instance. It's running on a $5 a month DigitalOcean droplet. And this $5 a month DigitalOcean droplet can support up to 75 per second. It can be different Jitsi Meet sessions, but the overall attendees is 70. We can join the Jitsi server with Jibri server, which is a little bit more resourceful server. And right now we have recording and auto upload options to AWS 3. The advantages is open source with community support. There is no license fee. We can fully integrate it with Microsoft Outlook, YouTube, Google, AWS, Dropbox, etc. And it has also APIs for your own application like EMS to utilize these Jitsi Meets URLs. It has increased security. It is end-to-end encrypted, but it also gives you your own data, which is also comes handy if you are going to use this in telemedicine because it is applicable with HIPAA compliance. Another advantage is increased performance, which not only lowers the costs, but it gives you freedom to the location of your servers. So if your clients are in Europe, you can create your servers in Jitsi Meet instantly and start a session there. The security offerings is, we talked about end-to-end encryption. We can password protect our meetings. We have random meeting name generator. If you are not using password protection, and if your URL is public, not running on a VPN, then there is the possibility of unwanted people joining your meeting, and this causes security, and this will lower the quality. This is the next component, which is Jibri, Jitsi recording and streaming infrastructure. It works by launching a Google Chrome instance and also X-Display, spinning up a X-Display on the Ubuntu server. But because of these requirements, it requires more resources, which is currently running on a different DigitalOcean droplet, which is $40 a month. This is a little bit expensive. Another optimization we need to make in the future is running more than one Jibri on one server, because downside of using Jibri is one Jibri can record only one Jitsi Meet in a given time. So if we have 5 simultaneous Jitsi Meet sessions, then we need to have 5 different Jibri servers, which we are working on it by trying to install it on Docker. JVB, Jitsi Video Bridge, is one of the other most important components. It is a XMPP server component. It allows multi-user video communication, and unlike the expensive dedicated hardware video bridges, it does not mix the video channels into a composite video stream. Rather, it relays the received video channels to all call participants. And again, this is running on our $5 cheap DigitalOcean droplet, because it doesn't require too much resources. How can we scale? We have 3 options. One is adding more JVB horizontally. The second one is duplicating the whole platform and putting a HA proxy in front of them. And third one is the most efficient, probably, is doing both. So adding more video bridges, it increases the number of simultaneously hosted conferences. We thought one Jitsi video bridge is supporting up to 75 participants. By adding more Jitsi video bridges, we can host more Jitsi Meet sessions and more participants. It also has the advantage of acting as a failover for our servers, which means if one bridge goes down, clients can jump into the second one. Third option is, if one server goes down, there will be still a server to create the meetings. We can use auto-scaling tools of the platforms like DigitalOcean, AWS, and Google Cloud. But we need to do automation. So what are the automation tasks we are figuring out is determining the requirements for scaling up, which is high load or high network. It's also the same for scaling down, but we need to be careful about scaling down, which if there is a Jitsi Meet session going on, no matter how much resource is downgraded, we cannot immediately close the session before the last meeting is over on that Jitsi video bridge. This is the schema of the previous slide, which the Jitsi video bridges adding to the prosody as a component. This is the second and third options, which is adding more Jitsi Meets shards, but also increasing the Jitsi video bridges in each shard, which is very functional and comes in handy, especially if we have clients all around the world. We can spin up new shards, one in South America, one in North America, or in Europe. It has the advantage of both sides. If one Jitsi video bridge goes down, the clients in Europe can jump into a second Jitsi video bridge in Europe. But if entire Europe shard goes down, they can still, with a lower quality, of course, go to the North America shard. We can leverage the geolocation service, but this doesn't always provide the best outcome, because sometimes people use VPNs and geolocation service may not be accurate. It still has a point of failure, which is if there's a failure on any of the video bridges which hosting a meeting, we cannot automatically jump the entire session into a new video bridge. So users will need to log off and log into the new URL. Here are a few metrics and also how Jitsi is implementing their own infrastructure. They are using AWS and they are separating the shards within different regions. There is 91,000 conferences a month in Meet.Jitsi. Average conference duration is 38 minutes and average participant count is 3 and 3 million conferencing minutes till today. 300 milliseconds is the round trip time. And our last component is HA proxy. We didn't give a significant amount of information here because it's out of our scope, but it's basically a high availability proxy which load balance the servers within different Jitsi Meets sessions. Now Dimitri is going to talk about the demo and the EMS integration.
Yeah, hi. So about talking about EMS integration, assuming that all servers has been started up on which will provide this capability of video conferencing, the EMS integration will only include two things. It will include providing URLs, secured URLs. Could you please go to the next slide? So the URLs to dedicated rooms for classes, so we can use either a very simple name, but it's against the security policy, I think, like ITU room 302, or we can use something like encoded SHA1 classroom for a person trying to get into the inappropriate room to not being able to guess the name. But we also can increase this security by using JW tokens, which is a capability of Jitsi right now. So the link overall will not only consist of a encoded room name, but also a very long token generated based on a secret word stored on a hosting server. So it can be on an ITU server. So how it can be used is it can be used not only for classes and recording classes, but also for various student services. Say on the next slide, I'm mentioning, say, ISO virtual visits for students. It can be student advising, it can be maybe student government meetings, it may be managerial meetings, all sorts of that. So you can imagine what you're using Zoom for now. You could use in-house video conferencing system. And to mention a live implementation, currently I am working as a part of my internship in a company located in Folsom. It's called Smile Time Dental. So Alp already mentioned HIPAA compliance. So we have implemented almost all parts of our current platform in that business. And it's working pretty well because that business took a beating from COVID-19 and it's required to implement teledentistry. So right now they are using teledentistry as a with the Jitsi Meets, and it is HIPAA compliant, so it's working out pretty good. And I would also try to, but before we go to our challenges and a future thing, I think we could demonstrate a small example of, I don't know, EMS demo integration, say, how it would be, how it look. It would look, and it's really easy. Oh, so you start sharing, right? So I can share the screen. Okay. So this, I hope you're seeing my screen right now. So I developed a very small application that can demonstrate. So it's like small IMS. So it's you can have a list of classes which every single item contains a link which leads you to an appropriate room. So far, we can say click on ethical hacking and go to presumably to ethical hacking class room. meeting room. So I will mute it here. So Alp, hello. Alp has
Hello.
Alp has started this room just beforehand, just to be able to do that. And maybe you can also record that room to be able to show that there is a recording existing for a particular
Yes,
class.
now I am going to record it.
Yeah, so for a student to be able to review the class which has passed, just to be, I don't know, be able to prepare for a midterm or refresh some of the parts of the lecture that has been provided. So currently we're storing that on AWS, but it can be anything, any cloud storage, and also be in-house. So yeah, I think you can stop recording and just show that it's there. Okay, and you will need to share, right? Okay, I will just go back and stop sharing. You can share up.
Yes, now I am sharing. So this is our AWS 3 instance, and this is the bucket for the recordings. And here is our recording. The naming, we are working on fixing it. I fixed it, but still needs to be tested. That's why I didn't push it into the production. So we can download it and later watch it, or we can stream it from the backend that Dimitri designed as a class on demand.
Yeah, we can also embed the link or the means of replaying this in our EMS as a part of our EMS integration on basically any product integration. So, and the next couple of slides is about our current challenges and future features and ways we need to work on. So, first of all, we will need to establish a clear strategy of deploying Jitsi on Docker, creating fully optimized Docker images to be deployed. We also need to work a bit on scalability right now to be able to fit more participants and load balance those. Latency may be a bit of an issue when 300 milliseconds maximum latency is not that good, but it can be improved. So integration can also needs maybe improved as a full-scale integration based, say, on a predefined platform like PHP, Ruby on Rails, Node.js, any backend, basically Go, I don't know. And yeah, some of the I would say bugs are maybe still there. Say, I'm not sure if you can really mute the particular person in the meeting. I think you can right now. So we're also thinking about Chrome extension as a means of easier joining incoming meetings or some kind of notifications parts and all that. Mobile app enhancements, say with a search inside the app to be able to search for a particular contact or room, or enhancing Google Calendar integrations within mobile application. We would like to also update some translations because it comes with an internationalization package. Yeah, so that's almost a list of tasks we are going to work on as a part of our next step of developing this project. And I believe this concludes our presentation, right? Thank you for your attention.